All right, let's take a look at problem number 4. So problem number 4 asks us to find the phasor of the current, voltage, and voltage of the resistance and voltage of the inductance. And then they also want us to find the phase relationship between V of S and the current. Okay. So they already defined a couple things in here for us. That'll be I, voltage. I'll pull this out to the side here so we can see it a little bit easier. V of S is equal to 10 cosine 500 t. Okay, and we notice that we have cosine here, so we don't need to change anything with the phase angle. So pulling some information out, we'll get 10 volts for the magnitude. We'll get 500 radians a second for the frequency. Then we're going to get 0 for that phase angle. Okay. But now that we've done that, let's go ahead and look at some of the things that we're going to have to do. So we have R is equal to 100 ohms. And then we have L is equal to 0.2 henries. Okay, so let's go ahead and convert these over to phasor. That'll be useful for us. So Z of R is just going to be equal to R at angle 0. So that'll be 100 at angle 0. Then Z of L will be J omega L. J omega we said was 500. And then 0.2 henries. So we will get J100, which is just equal to 100 at angle 90. Okay. Then up here as well, this will just be 100. And remember, all these values here are in ohms at the top for those impedances. That's also Z of L right there. Okay, so just keep an eye on that and that. Okay, so while we're here, let's go ahead and convert. Let's go ahead and convert this into the voltage source into phasor as well. So V of S is going to be 10 volts at angle 0. So we'll keep an eye on that as well. Okay. So they want us to determine I, VR, and VL. Well, the easiest thing for us to do initially is to go determine current first. So we see we have a closed loop here. So therefore, let's go ahead and do a KVL. So we will start at some points, say here, and we will work our way around. So we will assign negative V of S plus V of R, hitting the positive terminals, plus VL, and that'll be equal to 0. We'll end up back where we started. Okay. So therefore, we can rearrange this to say V of S is equal to V of R plus V of L. And we know from our Ohm's law that V is equal to IZ. So we can say that replacing I, because it's the same I is going to be in this current, I ZR plus I CL. So now we can simplify it down and say V of S is equal to I, open this bracket here, Z of R plus ZL. And we'll close that bracket off. Okay. So then now let's go ahead and rearrange this. So if we're trying to find the current, we will just do V of S divided by ZR plus Z of L. Let's just go ahead and plug all these values in. So I see here that I'm got an addition and then a division. So I know that I'm going to be dividing the voltage source. So I'll just go ahead and leave that in phasor. Like we had said in the concepts previous to this, that we want to do multiplication and division with phasor. And then in the bottom here, we have an addition. And once again, like the concept videos, we're going to use rectangular because they're easier to work with when we're adding and subtracting. So doing that, we'll sub in 100 for ZR, and we'll sub in J100 for ZL. Okay. Then we'll leave it like such, because now when we add all this together, it'll just be 100 and then J100. Okay. So, a quick side tangent here. Now that I get to do this division, I need to convert the denominator into phasor. So I'll just do we'll do this. We'll do a square root sum of the squares. So 100 squared plus 100 squared, square root of that. That gives us 141.42. And then theta is going to be equal to tangent inverse y over x. Where that'll be tangent inverse 100 over 100. Second. Inverse. And that'll give us an angle of 45 degrees. So if we continue on down here, we will find that we have 10 at angle 0, V of S. We'll have 141.42 at angle 45. Okay. So let's just go and divide the magnitudes like we do with phasor. We'll subtract the angles. Subtract the bottom from the top. And we'll get 0.0707 at an angle of negative 45 degrees. And that is our current in phasor form. All right. But now let's go find voltage in the resistance and voltage in the inductor. So voltage in the resistance, using our Ohm's law, will just be I Z of R. So if we go and plug this in, since we're doing multiplication, we'll just use 0.0707 and angle negative 45 degrees. Okay. Our Z of R, like we said, is going to be 100 at angle 0. So since we're doing the multiplication, we'll just multiply the magnitudes together. So 0.0707 times 100. And then we will add our angles together. So therefore, our voltage and our resistance is going to be equal to 7.07 at a negative 45 degree angle volts. And that's voltage in the resistance, complex voltage. Okay. Very similar, we'll do the voltage in the inductor. So I, Z, L, that looks like a 2, L. And since we're multiplying again, we'll use that phasor. Just subbing it in here. 190, like we had from the top right corner. Just like before, we will multiply the magnitudes together. We're going to add those angles. Okay, and doing that will give us 7.07 at an angle 45 degrees. Yep. Looks like it. Okay. So now these are our voltages across these two elements. Okay. But something to note, let's take a look at it. So here, we have this current, then we have this voltage and the resistance. So let's look at the phase angles. So I phase angle is negative 45 degrees. Okay. The resistance has negative 45 degrees. Do the voltage resistance, and then voltage in the inductance is equal to 45 degrees. Okay. This is a key note. I'm going to write this in red for you. Okay. So let's take a look. So how that concept that we say that the voltage and the current for a resistor is in phase. Notice how the same angles for both the current and the voltage. Okay, that's why we mean in phase. So if you're solving for those two values, those angles better be the same. Otherwise, you've made a mistake somewhere. Okay. We'll write this over here again real quick. They share the same current because they're the same loop. So that's why we write that. Okay. It's negative 45 degrees. All right, now let's look at these two. Okay, so these two, you notice here. So if we're looking at this, this is positive 45 degrees and this is negative 45 degrees, right? So if we drew that on a graph here, up here, this would be V of L. Down here, this would be I of L, where that would be 90 degrees. So there's 45 there, there's 45 there. Okay, and like how we said before, how originally up here, how this is positive 90 degrees, well, the voltage should be ahead of the current by 90 degrees. And if we take a look at this, here, plus 45 degrees, minus 45 degrees, plus 45 degrees, minus negative 45 degrees. That gives us plus 90 degrees. So this is correct. We should be always for inductor, the voltage should lead the current. Okay, mucho important right there. All right. So that's just a quick check to make sure that your values came out correct, looking at the phase angles. Knowing that is a very powerful concept, and that will help you on the test. Okay, well, I will see you in the last problem in the next video.